This is Algebra 1, Lesson 7-6, Simplifying Square Root Expressions. This is our last lesson of Unit 7, and then the final trilogy of Simplifying Square Roots. So you'll notice there's no backside of the page, so let's zoom in here at the front. Today's date is Friday, January 29th, 1/29, 2021. Our objective is just to simplify expressions that have square roots, but I'm going to throw you the hardest problems I can think of. Well, I can probably actually think of some harder ones, but this is like the penultimate level here. So I'm going to be giving you things of the form where I give you like 2 square roots and 2 constants. Constant is just like a fancy word for a number that aren't grouped yet. So you can see example 1, you can see example 2. I think example 3 is kind of just hard because it has 2 variables, but yeah, you can see what's going on. My general strategy is you just want to group your square roots. And I guess if I was being more specific, I would say group the square roots with all the square roots and group all the constants with the constants. So what does that look like? That looks like this. I'm going to have the 5 and the 7. Those are just the non-square roots, so those can be multiplied. So you can say 5 times 7. I'm not skipping any steps. I don't know why I can't say that word, skipping any steps. And then times, and then I'm going to group the square roots to say 3 times 2. They're underneath the same radical symbol. And then I could simplify yet again and say 5 times 7 is 35. And this is going to be root 3 times 2 is 6. So that's what we're looking for. Group the square roots. That's your big hint for today. So there's a lot of different ways to approach example number 1. If you want to give it a try on your own, I highly suggest it. Here we go. I want to show you actually a trick to do example 1 that makes you go faster, because here's the long way. Don't write this down. The long way is saying, okay, what do I have on the outside? I have 4 times 2, that's 8. What do I have on the inside? I have, oh gosh, 6 times 18. That's a big number. And you pull out your calculator and say, okay, 6 times 18 is 108. Oh my gosh, 108. And then I have x to the power of 3, x to the power of 2. You have the same base, so you're using properties of exponents. You get x to the power of 5, x to the power of 5. And then you begin the problems going, okay, what are the factors of 108? And you make the factor tree. I'm going to go ahead and write that down because we'll eventually get there. The factors of 108, and then you kind of make your factor tree, and maybe you'll just go through with your calculator and say, okay, 108 is that divisible by 4, and you go through all of your perfect squares, and you'll see, oh, it's divisible by 4. Is it divisible by 9? Oh, it's divisible by both 4 and 9. Well, what's 4 times 9? That's 36. Oh, okay, so it's 36 and 3, and eventually you could get the answer that way. That is perfectly valid. It's a slightly longer way of doing it, and if I don't give you a calculator, you're kind of stuck because, well, it's hard. 6 times 18. But we'll go ahead and show the long way. That's going to be the square root of 36 times the square root of 3, and that's one method of going about it. I'm going to stop right there and kind of reverse. How would you do the shortcut? Without doing all that, you could skip down and say, okay, I know 2 factors of 108. Do you know what they are? 6 and 18 are factors of 108 because I multiplied those together to get 108 in the first place. So here's your time saver. Go ahead and we don't know what this value is. It is actually 108, but just say, oh, I know the 2 branches that come off of that are 6 and 18. And then you can just keep going and doing factors of this. Don't forget my square roots. Okay, 6 is the square root of 2 times the square root of 3. Square root of 18 is the square root of 9, and the square root of 2, and yeah, the square root of 9 is perfect, and I can pull it out, but let's go ahead and do this, kind of like the brute force method that I was teaching in lesson 7-4. Square root of 3, square root of 3, circle the ends of my branches, 2, 3, 3, 3, 3, 2. And then I make pairs. I say, okay, I got a pair of 3's down here, so I can say this is going to be equal to 3 times, I got a pair of 2's right here, this pair of 2's right here, so 3 times 2, and I have this leftover square root of 3, so that's going to be the leftover square root of 3. And that's what I would have gotten over here, because the square root of 36 is 6 root 3, and over here I get 6 root 3. So there's 2 different methods that you have for doing that. But we haven't dealt with the variable yet. Either way, you need to know that somehow you have to boil this down to x to the power of 5. Let's figure out how to do that. So we know that, first of all, we have this. We have 6 root 3. That's the first half, just dealing with the constants, the non-variable terms. I either do it this method or this method. Either way, I get 6 root 3. the second part is, okay, well, what is the square root of x to the power 5? Square root of x to the power 5, that's a second problem. There's always two problems. I should kind of point that out also. Whenever you're dealing with all these problems, you'll first deal with all the constants, aka the numbers, and then you'll deal with the variables. So those are the two halves. I'm on the second half right now. And again, the way that you do this is you want even powers. So I'm going to say, okay, I'm going to separate this into the square root of x to the power 4 times the square root of just x to the power of 1, or just x. Why did I do that? I want even numbers, so I can rewrite this as x to the power of 2 to the power of 2. When I write to the power of 2 and square root will cancel each other out. I'll go ahead and rewrite that x while I'm at it. The square root of x is still there. Again, the square root and square cancels each other out, and I'm left with x squared times root x. So this is the variable answer, and I kind of squish everything together. I combine these two together. I shouldn't have written a, oops, I didn't want to grab all of that. I shouldn't have written the square around it because we're not done yet. These are kind of the two answers, and melding these together, all the non-square roots, I have 6x squared, 6x squared, and all the square roots, I have a 3 and an x in the square root, so square root of 3x. Final answer, and I can actually box that one. That is my final answer. All right, so there's two paths for doing these. Again, choose whichever one you think is easiest for you, that you like the best. Let's try another one. Example number 2. Again, I highly suggest pausing the video and trying this out on your own, and then you'll just learn better instead of just spectating me do it. Okay, so for this one, I'm going to use my shortcut method. I like it. It's easier to do. I don't have to use a calculator in case I don't have one on the test. Factor tree. Well, I know the two factors of these are going to be 15. I should say the square root of 15. Square root of 15. The other one is going to be the square root of 20, and then keep going on my factor tree. Okay, 15 is going to be the square root of 3 times the square root of 5. Can't go any farther. Square root of 20, that's the square root of 4, which is a nice number because that's actually a perfect square. And the square root of 5, hey, I see a pair already. And this is going to be square root of 2 times the square root of 2. All right, let's find, these are the ends of my branches. I always circle those so I don't accidentally mistakenly use any of those values. It's just the ends. All right, so make pairs. I've got a pair of 2s. I'm going to write 2 out here. Oh, maybe before I write all this stuff out, maybe I should rewrite the 3 and the 2 that are already there. Let's not forget about those. So let's use black to say, yes, we still have that 3, we still have that 2, and now this is going to be multiplied by, we have this pair of 2s I circled in green, so times that 2, I'll kind of draw an arrow, that's where that came from. We also have, I'll do a blue pair of 5s right here. That pair of 5s is right there. And we have this leftover square root of 3. I'll just say that's our leftover square root of 3. And I have all of this other stuff too. I have y to the power of 5, y to the power of 3, and y to the power of 1. So you add the exponents because that's your property of exponents. Whenever you multiply anything that has the same base, you just add their exponents. So I have 5 plus 3 plus 1. That's going to be 9. So I have square root of y to the power of 9. Alright, well, now I'm going to deal with this second problem. Again, how do I work with variables? So if I have, I'll rewrite square root of y to the power of 9. That's going to turn into, I want an even number, so I can write it as something square. That's going to turn into the square root of y to the power of 8 times the square root of y to the power of 1, or just y. That's a simplified version of this. Then from here I can say, well, y to the power of 8, that's y to the power of 4 to the power of 2. Again, I want to rewrite it to the power of 2 because that will let me cancel out the square root that I'm about to write right there. I'll go ahead and rewrite this square root of y as well, square root of y. As I said, the square root and square cancel each other out, and I am left with y to the power of 4 and this square root of y. So again, kind of this square root of y to the power of 9 really turns into this down here. So if I combine everything, there's a lot of math I'm going to do. First I'm going to say, what is 3 times 2? That's 6. 2 times 5 is 10. 6 times 10 is 60. So I'm going to say all those numbers out there, I don't know what color you use, red maybe, is 60. And I have another non-square root down here, that's y to the power of 4. And then finally I have my square roots. I have a square root of 3 and this square root of y that are going to be combined, so square root of 3y. Square root of 3y. A good way to know that you have the final answers, if you re-look at just the square root answer, is there any other perfect square that you can factor out of here? You say, no, there's no more perfect squares for the 3, and this y is as low as I can get it. It's not like y to the power of 2 or power of 3 or anything higher. All right, there's example number 2. I know these are difficult. Try example 3 on your own. Go ahead and pause the video now. All right, so now you're unpausing the video, and I really hope you are pausing the video. Maybe I'll use Edpuzzle or something to make you pause it. No tricks here. Again, we have to be worried about double variable, but let's first deal with the constant of 48. So my first problem is, how do I do the square root of 48? My next problem over here, I'll do it like an orange or something, is how do I do the square root of x to the power of 5 y to the power of 7, which probably will turn into 2 problems on its own, but that's kind of how I think about solving each of these problems. First deal with the numbers, then deal with the variables. And instead of saying numbers, I should say constants. I'll write it down over here. Whenever I use the word constant, what I really mean is number. So I'm going to deal with the constant over here, 48. All right, so factor tree this thing. Square root of 48. Well, I see 4 goes into this. In fact, I can be smart about this. 4 is a perfect square. Can 16 go into the 16 can go into this. I can just see, okay, this is the square root of 16 and square root of 3. Again, if you don't know this, you'll get more experience with finding perfect squares, but square root of 16 does go into there, and I'm done. I know that this can therefore be rewritten as the, well, square root of 16 is 4, and rewrite that square root of 3. All right, so done with the first half. It's a little bit tricky because I know 48, not everyone knows the factors very well. Now to deal with this variable part of the equation. I'm going to actually turn this one into 2 different problems on its own. So really I have the square root of x to the power of 5, and I have this second problem that is just the square root of y to the power of 7. So with the x's, the green half over here, I'm going to think of this as x to the power of 4, square root of x to the power of 4, times the square root of x. I want to make sure that it's an even number. Once it's even, then I can go ahead and rewrite that as x to the power of 2 to the power of 2. Again, still being square rooted, still having that square root of x. And yes, you know what's about to happen. The square root and square cancel each other out, and I'm just left with this x squared root x. Okay, what about for this black y to the, or square root of y to the power of 7? Again, I want to have an even power, so I'm going to write this as the square root of y to the power of 6, and then the extra y is going to come over here. I don't know if I've been explaining this well enough, but just remember that 6 plus this 1, whenever there's not a power here, you assume 1. 6 plus 1 does equal 7. From here, I can rewrite this as the square root of y to the power of 3 to the power of 2 times the square root of y. And you see what's about to happen here. The square root and square cancel each other out, and you're left with y to the, oh, I want to use black still, y to the power of 3 root y. Okay, we have these 3 pieces that we're all going to meld together. We have the black piece, we have this green piece, and we have this blue piece. Those 3 things I'm going to group all at the same time. So watch out, here we go. I'll even color code this. So what do we have? Let's do the non-square roots first. So I have the 4, I have the x squared, and I have the y to the power of 3. Okay, then I have the square root symbol, and then what is under the square root? Well, I first have that blue 3 from up here. I have this x, and I have that y. And I have my final answer. I will box it. All right, and zooming out, there are notes 7-6. Again, give yourself a fist of 5, at least in your head. How well can you simplify expressions that have square roots? This is like that penultimate level. How well can you do example 1, 2, and 3 if I just switch the numbers around a little bit? Hopefully you are at a 3 or above. If you are a 2 or beneath that, please, please, please send me a text message. You know my phone number. I'm not going to put it out on YouTube. You can also email me. You know that as well. And I'll see you guys on Monday, because it's Friday right now. So hopefully, I'm pretty sure we're going to be back in school in person on Monday. So I'll see you then.